Hello and welcome to the Chemistry Made Simple podcast. I'm your host, Matthew Macario, and this is the podcast where you get chemistry confident and we take you from point A to grade A. Hello, welcome back to the show. In recent episodes, we've been talking about quantum mechanics, and in this episode, we're going to go into a little bit more detail, and we're going to be talking about atomic orbitals. So what will we do? We'll define what atomic orbitals are. We'll talk about the different types of atomic orbital and which can exist in which electron shells or energy levels. And we'll talk about the number of orbitals in each subshell. Before we go any further, we must consider that we can't ever know the exact position and motion of an electron. We can only determine the probability of where it will be in space. And that's why we don't use our eyes to see an electron, but we use things like the Schrödinger wave equation to work out where it probably is. And those places where electrons probably are the atomic orbitals. Atomic orbitals are regions in the space around an atom's nucleus, where the electron is at least 95% likely to be located. The shape and size of this region depend upon the principal quantum number and the angular momentum quantum number, amongst other things. And you're unlikely to need to know the exact details, but you would likely be expected to recognise the shape of orbital types S, P and D, which we'll come to later, and also know how many electrons are in each orbital, which orbitals are available in which shells, how many orbitals of each type are there. Well, each individual orbital can accommodate up to 2 electrons, and if there are 2 electrons with a known orbital, they will have identical quantum numbers with the exception of the spin quantum number, which must be different, and there's only 2 settings for that. So in other words, when there's 2 electrons within the same orbital, one will have the spin characteristic we call up, and the other will have the down spin characteristic. Okay, so now we know a bit about what an orbital is and about how many electrons each orbital can accommodate to. Let's talk about the orbital types that I mentioned earlier. There are S, P, D and F orbitals. There are more, but we only need to know about those. It's important to know that each shell or energy level within an atom has a limited range of orbitals available. The first type of orbital we'll consider is the S orbital, and this is the only one that exists in every shell. It's available in the first electron shell or energy level and every subsequent shell. And the S orbital is spherical in shape. P orbitals are present from shell 2 onwards. Their shape is usually described as a dumbbell and has 2 lobes. I like to think of each lobe being tear-shaped, mirror images of each other, and those tears are touching each other at the point of each tear. D orbitals are available from shell 3 onwards. They have a variety of shapes, and there is more than one d orbital, as we'll come to. And F orbitals are available from shell 4 onwards. You don't really need to know much more about them than that. So if we were to summarise which orbitals are available in which shells, shell 1 has S orbitals available, shell 2 has S and P orbitals available, shell 3 has S, P and D orbitals available, shell 4 has S, P, D and F orbitals available. And just to complicate matters, we also need to consider how many orbitals there are of each type. For S orbitals, there is only 1 S orbital per shell. For P orbitals, there are 3 P orbitals for each shell they're available in. And there are 5 D orbitals for each shell they are in. And there's 7 F orbitals for each shell they're in too. This is why we have a growing capacity for how many electrons each shell can accommodate as the energy level increases. The first shell only has an S orbital, so can only accommodate 2 electrons, 2 per orbital, remember. The second shell has an S and 3 P orbitals available, meaning that the second shell can accommodate up to 8 electrons in the 4 orbitals. And so on, the third shell increasing because there are also d orbitals, the fourth shell increasing in electron capacity because there are s orbitals, p orbitals, d orbitals, and f orbitals. I do have a PDF download available on this topic as well. And to get that, just go to chemistrymadesimple.net/orbital, and that link is in the show notes. So time to summarize what we've talked about today. We've said that orbitals are a region of space in an atom where electrons probably are. And we talk about probability because we can't know the exact location and movement of an electron. We've talked about different types of atomic orbital, S, P, D, and F. We've talked about how many electrons can be accommodated in each orbital. We've talked about the different types of atomic orbitals, S, P, D, and F, and in which shells or energy levels they're available to. And then we mentioned why that means the electron capacity of each electron shell increases as the energy level moves away from the nucleus, as the energy level number increases. So I hope that's been useful, and I look forward to speaking to you again in the next episode. Thank you for listening to this episode. I hope you found it useful, and if you have had value from it, do consider visiting our Patreon community at patreon.com/chemistrymadesimple, where you'll be able to ask deeper questions about this topic and get more support for your studies too. So I look forward to speaking to you again in the next episode, and until then, do look after yourself, and goodbye.